Hello, everyone. I'm Daniel Roth, Principal Product Manager for ASP.NET Core and Blazor on the .NET team. And I'm excited to be here with you today to talk about building better web apps with Blazor in .NET 10. Blazor is a web framework for building full-stack web apps with C# and .NET. With Blazor, you can build your entire app from the front end to the back end using a single language and framework, no JavaScript required. At its core, Blazor is about building reusable UI components with C# and HTML and CSS. It includes a rich set of built-in components and a large ecosystem of third-party libraries to help you build apps faster. Blazor offers flexible rendering, so you can run your components from the server or from the client, like on WebAssembly or using a hybrid native application. It's optimized for performance. It has security features built in, and it allows seamless interoperability with JavaScript when you need it. Blazor is great for building web apps both big and small. The MyRide K-12 app from Tyler Technologies is a great example of how Blazor enables developers to be maximally productive. The MyRide app helps parents track student bus routes and transportation schedules. The app is used by over 2,500 K-12 schools across the United States and Canada, and it has over 750,000 downloads on the Google and Apple app stores. MyRide uses Blazor to target the web and also native devices at the same time. It's built by a small, agile team of engineers with incredible results. When they make a UI update, it's immediately available across platforms, which increases agility and reduces costs. LKAB, Europe's largest iron ore producer, transformed its mobile strategy by adopting .NET MAUI and Blazor. Previously, apps were built using multiple different frameworks, creating high maintenance costs. Today, a unified Blazor-based approach powers cross-platform apps for iOS, Android, Windows, and soon the web, all from a single code base. This shift has streamlined development, reduced maintenance overhead, and accelerated delivery of new features, improving productivity across the organization. Blazor is also great for building AI-powered web apps. Blazor's powerful server-side rendering model makes building rich interactive AI experiences surprisingly easy. You can get started using Blazor to build AI-powered apps with the .NET AI Chat web app template. This template is more than just a basic chat app. It shows you how to build Blazor components that handle streaming responses, markdown rendering, citations, and suggested prompts. The template works with a variety of AI services and also integrates with various vector stores for retrieval-augmented generation. The template also includes Aspire, so your AI app is cloud-ready, and it's easy to monitor and troubleshoot all those AI interactions. To get started with the .NET AI Chat web app template, check out the Quick Start at ak.ms/.net/AI-templates. Blazor is now even better in .NET 10, the latest release of the .NET platform. We're so excited for you to try out this new release. In .NET 10, we focused on 4 key areas for ASP.NET Core and Blazor. Simplified security, making it easier for you to build secure apps. Better observability and diagnostics. Improved performance. And delighting developers by addressing those top pain points and feature gaps. Let's take a look at each of these areas. So first, in .NET 10, we want to make it easier for you to build secure web apps with ASP.NET Core and Blazor. To do that, we've added built-in support for passwordless authentication using WebAuthN and passkeys. I'll talk more about passkeys in just a moment. We're also working on new authentication scaffolders to make it easier to add authentication to your existing apps. The new Entra ID scaffolder for setting up Entra ID authentication for ASP.NET Core and Blazor is now available from the command line using the .NET Scaffold tool. With .NET 10, passkey support is now integrated with the Blazor web app template, and it's supported by ASP.NET Core Identity. Passkeys are cryptographic credentials that replace traditional passwords. They're phishing resistant, they're easy to use, and they're secure by design. A passkey consists of a public-private key pair scoped to a particular account and origin. The private key is stored in an authenticator app. The authenticator then takes care of verifying the user identity before allowing authentication with that stored passkey. Let me show you how easy it is to get started with passkeys with Blazor in .NET 10. OK, so here I have Visual Studio 2026, the latest release of Visual Studio. And I've created a new Blazor web app, and I've checked the checkbox to say I would like to have individual user accounts so that we've set up authentication. And if we look in here, we should be able to see, yep, right there, we're seeing some passkey code. There's passkeys already set up in this app. Now I've got it running, and I've gone ahead and set up a user and set up the schema in the database. So I'm logged in as myself. Oop, I just logged myself out. So let's log back in. There we go. So here I'm going to use a password. Ick, don't want to use passwords anymore. But once I'm logged in, I can see my user account. And if I go to this passkeys tab, you can see now I have the ability to add a passkey to log in without having to use a password. So I'm going to add a new passkey. When I do that, I have a choice of which authenticator app I'd like to use to store that passkey. I could use Windows, for example, or I have other options. Like I could, for example, use like my phone or a security key. I'm going to go ahead and use Windows. And Windows is first going to verify that I am really who I say I am, so that you can't store passkeys for somebody else. And then I can give that passkey a name. We'll just call this one Windows. We'll go ahead and save that. All right, great. So now I should be able to log in with my passkey. Let me log out again. And then this time I'm going to click the login with passkey link at the bottom here. And here the Windows is saying, let me make sure first that this is really Dan. And I'll go ahead and authenticate myself. And that should allow me to log in using that stored passkey. It's just that simple. So this is built into the new Blazor identity code that's part of the Blazor web app template. We're also updating the Blazor identity scaffolder, so it's included there as well. Awesome. All right. Next, let's talk about observability and diagnostics. So in .NET 10, we've made it easier for you to monitor and diagnose issues in your ASP.NET Core and Blazor apps. We now have lots of Blazor-specific metrics, like metrics for page navigations, UI events, how many active circuits you have, and more. We've also improved tracing for Blazor server apps, so you can see the activities associated with specific page loads and events. We also have added new diagnostic tools for Blazor WebAssembly apps, so you can collect performance profiles, memory dumps, and runtime metrics. Let me show you that. OK, so let's go back over here to Visual Studio. The easiest way actually to see the new metrics and tracing in .NET 10 is to use .NET Aspire. So I'm going to go ahead and right-click on my project, and I'm going to say, let's add Aspire Orchestrator support. There we go. And I'm going to use the latest version of Aspire, Aspire 13, the first of the prime version Aspire releases. It's very mathematically pure. All right, there we go. So by adding Aspire, I now have this app host project and a service defaults project. The app host project is going to let me orchestrate and manage my entire distributed app. And that service defaults project is going to set up open telemetry and collect all the distributed traces so that we can see that in the Aspire dashboard. So once we get this running, we should be able to see all that information. There it goes. All right, cool. All right, so here we've got the Aspire dashboard open. And let's go ahead and browse to the app, which shows up as one of the resources. Here's our app. And let's just create some data by like clicking around a little bit. Browse to the weather page, back to the home page, back to the counter. There we go. OK, so now if we go to the metrics tab, we should be able to see all the new metrics. And there are a lot of new metrics in ASP.NET Core. Like there's new metrics for authentication and authorization that Safi and Mike showed earlier. But we also have great Blazor metrics. For example, we can see how many times people have browsed to the different pages in our app. We've got like 5 total page navigations right now, but we can of course filter that to specific routes. Like if I want to see how many times have I browsed to the counter page, we can look at that route and say, yep, I've browsed there twice. Similarly for the weather page and so on. Alternatively, if we want to filter by specific component types, we can see, how many times did I actually browse to the weather component? And we can see, yep, I browsed there once. We also get a bunch of telemetry on the UI events and how long they're taking. Like this could be useful for like performance investigations. If you have some user interaction that's taking a little longer, you can filter down to specific event types and then specific event callbacks and see what's going on there. We have some lower level component lifecycle metrics that give you information about your render diff sizes and durations for your components. That's useful like for optimizing and monitoring the rendering performance of components in your app. But what I really love is the new circuit metrics, where you can see how many active circuits you have in your app. It's kind of like how many users you have currently using your application. Right now I only have one because I only have this one counter page open, but if I duplicate this tab, so I have 2 counters, I should see now that it jumps up to 2 active circuits, and yes, it does. I can also see how many of those circuits are actually in a connected state, like have an actual active network connection versus being disconnected and just sort of waiting to see if the user's going to come back. Okay, so that's new metrics and tracing for server-based Blazor applications. What about WebAssembly? Let's close all this, and let me open up a WebAssembly-based application. This one's just using server rendering, so let's switch to that. So let's go to this Blazor diagnostics application. There we go. Okay, so this is using Blazor WebAssembly, and you can see here I had to do a little bit of configuration in the client project to configure the WebAssembly runtime so I can collect diagnostic information from the runtime. So it's a bunch of MS Build properties. You can read the docs for details on all of those. But once you've done that, we can now run the application and export or extract diagnostic information from the running application using some new convenient JavaScript APIs. So let's go ahead to the counter page. This is the page that's actually using WebAssembly, and I'll bring up the browser dev tools. And let's go ahead and make sure the counter's working. It is. Okay, so here are some of the new JavaScript APIs that you can use. You can collect a performance profile using CPU sampling, like for a particular duration. And this will generate a net trace file that you can then download and analyze. You can also collect a GC dump, a memory dump of the memory usage that's in the application. So that's useful. And then we also have, let me make sure we don't have that 2 hanging out there. We also have the ability to collect runtime metrics, like low-level runtime metrics from the runtime itself. So just as an example, let's go ahead and collect a memory dump. I'll do a GC dump, and that, as you can see above, it just added this particular trace file. So 7450.net trace. And what I actually want to do is, I'd like to open that up in Visual Studio. Visual Studio actually we would prefer to have a GC dump file. So in order to turn this net trace file into a GC dump file, I'm just going to use a simple .NET SDK tool, the GC dump tool, and I'll just say convert, and the trace file, there we go. That should turn it into a GC dump file, and now I can open that up in Visual Studio. And let's go back to my downloads folder where I can find that, and we should be able to see some memory information about my Blazor WebAssembly app. Yeah, there we go. So somewhere in here I should have like my my counter component. Yeah, there it is. That's the counter component for my counter page. Okay, so you've got tools now where you can extract diagnostic information from your Blazor WebAssembly apps. We have new metrics and traces for your Blazor server applications. Very nice. All right. Next, let's talk about performance. So we want to make sure that .NET 10 is the fastest release of Blazor yet, so we've made a number of optimizations. The Blazor framework scripts are now provided fingerprinted, pre-compressed, and cached, just like all of your other static web assets in your ASP.NET Core applications, so that they load faster. We also now preload the Blazor WebAssembly runtime scripts so that you don't have to wait for a cascade of requests before the runtime actually boots up and loads. So that makes your app start up faster as well. We've also improved runtime execution performance. The chart that you see on the left, this is a bunch of counts of the number of .NET micro benchmarks that have shown either performance improvements or regressions compared to .NET 9 in .NET 10. So green means good. That means that was a performance improvement. Red means there's some regression that we could probably still look at. And the further to the left in the chart that you go, the bigger the change. So the one on the farthest left, those are performance changes greater than 50%. So you've got that nice big tall green bar. That means we have tons of benchmarks that are now significantly faster in .NET 10 than .NET 9, and you can see mostly green across the board. So that looks good. Does this actually translate into real-world performance? The answer is yes. The chart on the right that you see is our Blazor component rendering benchmark, and you can see that compared to .NET 9, we now have 20% faster rendering of Blazor components on WebAssembly in the .NET 10 release. So much better performance in .NET 10, looking great. Now, one of the really nice things about platform improvements in performance is that your app just gets faster for free by upgrading to the latest .NET version. This was certainly true for Microsoft Copilot Studio. Copilot Studio leverages .NET WebAssembly to run C# code directly in the browser, enabling a consistent experience for building AI agents and automation across their various clients. When Copilot Studio upgraded from .NET 6 to .NET 8, they saw significant improvements in load time and runtime execution performance. They haven't quite done their .NET 10 upgrade yet, but we're working with them on that. And when they do, we expect to see even more performance improvements in their measurements. We'll keep you updated on that. All right, lastly, we've done a lot of work in .NET 10 to delight developers by addressing top pain points and gaps in Blazor development. One top area of feedback is hot reload. We've been working really closely with the Visual Studio team to make hot reload with Blazor faster and more reliable. We've also added support for state persistence to the Blazor framework to address many of the common pain points with the stateful nature of Blazor server apps. I'll talk more about that in just a minute. Enhanced form validation. Blazor form validation now supports validating nested models, making it easier to build complex forms. We've improved the handling of not found responses in Blazor apps. We now have a proper not found page in the template that you can use. We made Blazor's navigation behavior more consistent across render modes. We've also improved the behavior of enhanced navigation and how it handles scroll positions. We did a bunch of QuickGrid improvements so that you now get a bunch of top requested features like being able to add row classes and be able to control when column options are hidden or visible. We've smoothed out our JavaScript interop stories so it's easier to work with JavaScript properties, constructors, and callbacks. And we've made it easier to do automated browser testing of Blazor apps with Web Application Factory and Kestrel. All right. Now this is a side-by-side comparison of hot reload with Visual Studio 2026 Insider Edition versus Visual Studio 2022. This is a change that's being applied to the MudBlazor sample app. MudBlazor is a very popular open source Blazor component library. It's a fairly big application. But as you can see, if you try to apply change to that app, yeah, it takes a little while. Not so hot. It actually takes like 40 seconds to apply that change to the app. And it is big, but still, we can do better. In Visual Studio 2026 Insider Edition, that change just takes 3 seconds, over 10 times faster. And we're not done yet. We continue to work to make hot reload faster and more reliable so that you can be as productive as possible. All right, let me show you also the enhanced form validation in Blazor. Let me pop out here and go back to Visual Studio. All right, let's open this Blazor validation project. Okay, so in here, I have a model type that is a complex graph. It's a deeply nested model. Like we've got an order model, and it has the customer that made the order, and it's got a list of order items on it. If we look at the customer model, it's got a name, an email address, but then also it's got a shipping address, which has its own model type. And then we've got the order item model type as well. And if we look at this model, all of these types have data annotations throughout them defining various validation logic, things that are required, things that need to be specific format, like email addresses, lengths of things, and so on. Previously, Blazor would have only validated the top level of this model. But in .NET 10, we can now validate the whole object graph. And you don't have to do anything really different with your forms. Like this is the form that I'm using for that's based off of that model. You can see right up here, I'm passing in the order model, and I'm just using the normal data annotations validator component, just like you always would. The one change that I did have to make is in program CS, I did add this one call to builder.services.addValidation, which will register the new validation services that are used both by Blazor and also by minimal APIs, which you saw earlier with Safia and Mike. Okay, so if we now run this application and take a look at the form, it's a fairly elaborate form. If I just go ahead and submit it without inputting anything, all the required fields like kick in. If I start filling stuff out, like let's order some pizzas for me. Let me put my email address in here. Things start being validated. Actually, let's mistype my email address so it's not actually a real email address. Yep, invalid email address. I actually add a proper @ sign in there. Then that validates. Great. Let's send this to Microsoft and zip code. That's putting not enough characters. Oh, yep, okay, so let's make that all 5 characters. There we go. And what kind of pizza should we order? Let's order some Hawaiian pizza. I know that's controversial, so we'll let's tell them the hold the pineapple. No pineapple on the Hawaiian pizza. Oddly, that does validate. But if I ask for 200 of them, that won't. And then if I just ask for 2, then it's fine. So you can see we're able to validate the whole graph. So that's the new enhanced validation support in Blazor. Let me also show you automated browser testing. Let me switch to this other project. So ASP.NET Core has long had a really nice feature, which is this web application factory type that you can use to basically run an application entirely in memory and send requests to it using an HTTP client. So you can see here I have a Blazor web application factory. And if I go look at that type, it's derived from web application factory. And you can do things like configure mockout services and stuff like that. So you can customize it for your integration test. Now before, this was worked pretty well for like testing APIs, like you could request an HTTP client and send in-memory requests to the application. But for web apps, that's often not enough. Like often with web apps, you need a full browser to really exercise its functionality. So now you can say web application factory, use Kestrel, which actually will create an actual endpoint. And then here you can see that we're using this is a Playwright in order to do an automated browser test of our application. So if we go and let's just do like run tests on the weather page tests. And look at the test explorer. That should kick off Playwright. Use web application factory to stand up a Kestrel endpoint that we can use for testing, mock out the weather service, and hopefully that test should pass and work appropriately. See, it does. Takes usually just a second for the browser to get a chance to load, and there it goes. So our weather test passed just fine. And you can use this also with MVC and Razor Pages apps as well. Works for them too. All right, last thing that I want to show you is Blazor state persistence. All right, one of the biggest investments that we've made in Blazor for .NET 10 is support for state persistence, which simplifies pre-rendering and also helps improve app resiliency and scalability. Blazor has a new declarative model for declaring a persistent component state that you can use when pre-rendering instead of having to mess around with the persistent component state service. You can just define a property and put the persistent state attribute on it, and Blazor will take care of the rest. It'll persist the state into the pre-rendered page and load it at the appropriate time. We also will now automatically persist the state of disconnected circuits before they get evicted. A circuit can get disconnected from its user, a bunch of simple cases, like maybe the user has the browser open but on their mobile phone, but they swipe away. The browsers in the background will often kill the connections. Today, Blazor will wait to see if the user connects for like a few minutes, but after that, it will evict the circuit to free up those resources. In 10, we can now persist the state of that circuit so that its state is available for much longer, and we can reload the circuit at a later point. You can also use state persistence to improve the scalability of your Blazor applications. By using new APIs that we give you so you can pause and resume circuits. This is useful for things like if you want to to improve scalability, like if you have a circuit that's idle, like maybe the user opened your app and then went to lunch and just left it there, and the circuit's not really doing anything. You could pause that circuit to free up those resources and then reload it later when the user comes back. So let me show you what this looks like. All right, so I got this Blazor state persistence application, and this is just a normal Blazor web app. I've only made 2 changes really. In the counter page, I've changed the current count from a field to be a property and added the persistent state attribute so that it will now be persisted at the appropriate time. And then I also made a little change to app.razor to add a little bit of JavaScript. Not too much, just a little bit for demo purposes, that will hook the visibility change event on the browser. If the browser is hidden, then the user's not using that app. We might as well pause the circuit. If the browser is visible, then we can resume the circuit and hopefully keep that user state around. All right, so let's go ahead and run this and see how this works. All right, so this is using Aspire again, so we can see the metrics and see what's going on. Let me just open up a couple of browser tabs, and let's do a little bit of layout here. Let's make this on the side, that one on the top, that one on the bottom, and give myself a little bit more space. And let's browse to the counter on both of these browser tabs. Let's get some counts in here. And these counts are really important. I don't want to lose them. They're super precious to me. Okay? All right, so let's see what's happening with our metrics. How many circuits do we currently have? Well, I currently have 2. Yeah, I've got 2 pages. But let's say this user at the top right, they browse through a different tab and start watching YouTube or whatever. So they're not using the app anymore. And maybe this user down here on the bottom, they go start checking their email, so the browser is no longer visible there either. You can see that the number of circuits is dropping. Like it just dropped to 1 when I changed tabs, and now it's just dropped to 0. I literally have no active circuits in this app. I've saved all those server resources. But if the users then come back, like let's say I close that tab, or I click on bring the browser back up to the forefront, you can see now I'm back up to 2 circuits. And notice I didn't lose my state. I still have the count. That was the circuits were paused, they were saved, and then the state was later restored. So this can help make your apps more scalable, also more reliable, and it also helps with pre-rendering scenarios. So that's the new Blazor state persistence. All right. So that's what I had to show you today. Here's a summary of what's new in Blazor in .NET 10. Blazor in .NET 10 is loaded with significant advancements in security, observability, performance, and developer experience. You can get started today with Blazor in .NET 10 by going to blazor.net. We're excited to see what you'll build with these new features.